Hello everyone and welcome back to another video here at the Hidden Quantum Champions. Today we are going to look into SpinQ, which is one of Chinese probably most famous and most interesting companies in the space of quantum. And if you want to know what China is set up for and what they are actually working on, what this company is doing, then stay tuned for today's video, grab yourself something to drink, and let's dive into the world of SpinQ. So, as always, here we are at the website of SpinQ. As you can already see here in the logo, it says also something in Chinese. Unfortunately, my Mandarin is not good enough to really say what is below here, so I stay with the Western version, which is SpinQ. You can see here already some chip. There's also a video attached to it, which we are not going to view today. Oh, now maybe I broke it. And there's also some other things connected here, but let's dive right into what the website is telling us. So here we see, driven by both technology, R&D and commercialization, industrial-grade superconducting quantum products and services. From QPU, so quantum processing units, and QPU EDA, to quantum control and measurement systems, SpinQ offers a full-stack product ecosystem, including superconducting quantum computers, algorithms, and software to provide customers with cost-effective modular units, integrated systems, and complete solutions, paving the way for industrial applications. And then what we can see here is the typical cryostat setup that you would expect for these superconducting qubits. And I mean, we've talked about superconducting qubits before, right? So you have a cryostat, a dilution refrigeration cryostat, where inside you will have the QPU, the quantum chip in here. Then you have usually some radio frequency electronics control lines that are going up in here. That's this chandelier that you might already know. And then up here, usually you have a breakout where all the wires are coming off and they go into this EDA control rack in here. So they make the chip. They also make the control electronics. So this part here. And on top of that, also quantum control measurement systems and the full stack software solution and algorithms and so on. So probably also some additional solutions. But this is actually quite new. What I know them for is more what we can see down here. Because SpinQ is also an education provider in a sense. Because what they are making is, they're making these NMR systems here, so nuclear magnetic resonance, where you have some, let's say, molecule inside a little vial in a liquid. You put it in a magnetic field and then you can actually use certain pulses to control the spin orientation of these molecules, different states in there. And you can actually use them as qubits more or less. Actually, you're always measuring an ensemble, so multiple of these. It's not just a single one as you would expect, for example, in one of those machines where you can really, let's say, use the circuits, the chips to create single quantum systems. Here you really have a multitude of those. But the nice thing about this piece of technology is, and you can see that here on this image, that it's something that you can easily put on a table. You can put it in a nice little enclosure and then you can make it tangible so you can touch it. And I have to say, maybe I'm also a little bit biased here. I had the pleasure of visiting my quantum friends here in Switzerland, and they actually have one and they showed me that. And I also wrote a LinkedIn post about that. So if you want to know more about that, check out my LinkedIn. And I was very excited. I could really see the algorithms being, let's say, played on this kind of system. It was one of those up here. You could also look inside. You could see the magnets and the little vials sitting in there. So very, very interesting. What does it say here? It says the SpinQ education grade NMR quantum computer series is based on the principles of nuclear magnetic resonance, NMR, quantum computing. Currently, various models, including experimental, desktop, and portable versions, have been launched. These products are characterized by low cost, maintenance-free operation, and high stability, offering a complete set of products and services for quantum computing research and teaching. And then, you can learn more about those. Then there's also something here about the software suite. So that's what was already mentioned above, right? And also these ones here, I mean, they also come with some software. It says quantum computing cloud platform and software. It includes a cloud service platform and related software linking to a variety of real quantum computing systems in which the cloud platform supports graphical quantum line design and online chasm programming, as well as user-defined quantum gates and a variety of built-in typical quantum algorithms to meet the different needs of scientific research, education, and enthusiasts. So as we can see here, and I mean we can also see that here in the interface, this is in no means anything, let's say, from what we know at this point, less than what we've also seen with other companies in the Western hemisphere, right? So you have the quantum computer, you have the software interface, there's a cloud access to that. So very, very sophisticated setup as well. Here it says co-building scenario-based solutions with partners. So there's education solutions, but there are also solutions here in the fintech, in the biomedical, and in the AI-based space. Let us quickly go through these. So what are actually the markets where they have already some traction? Well, it all started, I think, in the education. It says quantum education solution. We provide comprehensive and cutting-edge quantum education solution tailored for universities, K-12 education, and various science popularization scenarios. By combining in-depth theoretical teaching with practical expertises, we offer customized classroom setups, professional teaching teams, and educational quantum computing equipment to help teachers and students master essential future skills in quantum computing. In the fintech case, it says fintech-based solution. Quantum computing has a wide range of application scenarios in fintech, including portfolio optimization, which is one that we've heard about in the past before, risk management, and predictive modeling. By leveraging the super parallelism of quantum computing, investors can optimize their portfolios more efficiently and increase returns while reducing risk. Quantum computing can also accelerate the modeling and simulation processes of large-scale complex systems, which is of immense value in scenarios such as market trend analysis, credit rating, and fraud detection. Quantum computing not only improves the efficiency of financial operations, but also helps enable more accurate forecasting and management decisions. Indeed, I'm interested to learn more, but we will not go into that right now. But of course, these are all, let's say, very interesting promises that are being made here. And of course, the question is, can quantum computers already deliver that? And I think it's not entirely clear when reading that. Can quantum computers already deliver that? Or will they be able to deliver that in the future? And this is not only the question for SpinQ, but I mean in general. This is a question. Biomedical based solution. Maybe I should drink something. It says biomedical based solution applications of quantum computing in the biomedical field include gene sequencing, drug discovery, and disease modeling. Quick comment from my side. These are also points that we've seen with other companies before that are looking into where can you actually use quantum computers on the one hand as, let's say, a promotion of quantum computing manufacturers, but also of these software platforms. And we've seen specific ones that are, let's say, targeting or catering to some of these cases also in particular. End of my note. So we can use quantum computers to simulate complex chemical structures at the molecular level, which can also help predict the interactions of new drugs with organisms and speed up the development of new drugs. In addition, quantum computing can also process and analyze genetic data more efficiently, providing more possibilities for diagnosis and treatment. Overall, quantum computing in the biomedical field can improve R&D efficiency, reduce costs, and in the future help achieve the goal of personalized medicine. And then finally, the AI-based part, which I guess is also something that we've seen before, using the Hilbert space with some variational quantum eigensolver kind of ansatz to create some AI that runs on the quantum computer. Here it says AI-based solution. Quantum machine learning is an emerging field that leverages quantum computing to improve the performance of traditional artificial intelligence and has applications in computer vision, natural language processing, reinforcement learning, recommender systems, and other directions. The parallel nature of quantum computing can improve the efficiency of neural network training and optimization, and is also useful for faster and more accurate solving of complex system models. Overall, quantum computing can not only accelerate the computational speed of AI, but also improve the accuracy of its problem processing and decision making, and promote the innovation and development of AI technology. And then finally, there are also some press releases here about certain, collaborations. An interesting one also on the hundreds of millions in Series B funding, which we are going to check out a little later. Finally, there are also some collaborations which are mentioned here, like for example with MIT in the US, French universities, I think, but also like Fraunhofer in Germany. So across the globe, like various different universities, and of course Chinese ones as well. Taiwanese, you see here, Australia, so many different collaborations across the globe. So not something that you can actually only find in China. So maybe I was a bit provocative in the introduction part and in the opener. Quickly on the products. So let's check out the superconducting one in a little bit more detail. So superconducting quantum products and services. Let's see if we can also figure out how many qubits it actually has. So SpinQ SQC, superconducting quantum computer. It leverages circuits with Josephson junctions where qubits are formed by macroscopic quantum effects. This method offers scalable qubit numbers, high gate fidelity, and controllable multi-qubit coupling, making it the most rapidly advancing and industrialized quantum computing technology. And indeed, it's also the approach that IBM and Google are currently following in their main stream, in their main development stream. Let's say it like that. On the QPU, so here we see different ones. The C10 SpinQ Series C, designed and fabricated by SpinQ. The QPU C series superconducting quantum chips are engineered for high coherence and high stability quantum computing applications. Operating at ultra-low temperatures of around 20 millikelvin, each chip features a high factor, extended coherence times, and excellent circuit uniformity. As the core foundation of SpinQ's self-developed superconducting quantum computing architecture, the QPU-C series provides the critical hardware basis for building scalable high-performance quantum processors. And I think this is about the same text here. Yeah, it's all the same. I assume, but this is now just my best guess, because it's not explicitly written here, that this number might indicate the number of qubits. So you see that in this case it would be 10, here we would have 25, and this would be 103. For sure, this one has less than this one, because here you see there's more radio frequency connection lines around the chip. So probably that means there's more happening in there. But it's not explicitly stated here. Maybe if we click here on Learn More, which we will maybe do in a second. But then let's also quickly look at the electronic system. So here it says SpinQ, a QCM system, is designed for high compatibility with superconducting QPUs and features a modular architecture with high precision radio frequency control electronics. It is versatile, supporting various quantum computing platforms and capable of managing the measurement and control of hundreds of qubits. So probably we are in the hundreds here. Utilizing FPGA for hardware level acceleration, the system offers high vertical resolution and includes extensive tutorial codes for qubit characterization and calibration. This ensures users can achieve faster, more accurate, and more efficient qubit measurement control. Quick little note, because I haven't said it in a quite long time. If you would be interested in learning how to program one of these, let me know down in the comments below. And then we will try to actually get our hands onto the cloud and play around with one of these SpinQ systems, and also maybe do a little tutorial on how to use them. Then QPU Foundry and Characterization Services. SpinQ provides QPU Foundry services and professional QPU characterization. Our goal is to support companies and institutions that lack the necessary equipment or expertise, aiding them in the development and application of quantum computing technology. Also something that we've seen before, so they have their own clean rooms, they make the chips themselves, and they also test them. Testing usually includes some type of room temperature characterization, like for example with a microscope here, seeing if there are like some optical defects, but possibly also some cryogenic testing. And here it also says cryogenic environment development services, so millikelvin cryogenic systems down to 10 millikelvin are required to probably operate superconducting qubits. SpinQ offers comprehensive cryogenic environment development services and solutions, including selection, consulting, supply, maintenance, and upgrading of dilution refrigerators and other necessary components. SpinQ aims to ensure a stable and high-performance experimental environment for our users. So here they don't make the cryostats themselves, but they advise into which one to use, which one to select, as far as I understand from this. Let's quickly check on the QPU itself here, because that might be interesting also for you as a viewer. And yeah, indeed. So what we see here, it says 103 superconducting qubits. So the architecture supports high density integration of 103 superconducting qubits and provides native support for quantum error correction, enabling surface code with code density up to d equals 7. So this is, let's say, very expert jargon already, and I'm not going to go into the details of this in particular. First of all, because I'm not an expert for error encoding, but also because it probably requires a different, let's say, session to talk about that. But what is important is we need error correction in order to build algorithms. There are different ways of doing that, different encoding levels. So surface code with a distance of up to d equals 7 is, I think, already from a technical point of view, something quite advanced for today's systems. And yeah, it's interesting. So that also seems to be part of the offering, which of course is also something that happens on both hardware and software side in a way. Advantages, so maybe something that makes them also unique, standardized and mass produced through standardized QPU design, simulation, fabrication, packaging, and testing process. SpinQ has achieved the capability to produce commercial viable high performance QPUs. Then robust performance and fully controllable qubits. Users can achieve high precision control over each qubit through independent control lines when combined with SpinQ's QCM system. This setup enables high fidelity quantum logic gate operation on SpinQ's QPUs. And here we see those qubits, we see the readout lines and the couplers between those. And then also the topology of this specific case here, which has 10, I think, 20 units on it. Flexible operations for diverse applications. So SpinQ QPU products are available in various configurations with different numbers of qubits, catering to diverse application scenarios and budget requirements. Stable and reliable, highly integrated, easy to use. So SpinQ's QPUs are fully packaged for straightforward installation and use in any experimental environment, eliminating the need of additional handling. They offer high flexible and excellent thermal contact performance and ensuring stability and reliability. So this is the stack of the technology, right? So in here you see the silicon, which is the actual chip, which has the superconductors on it. Here on the borders of it, you see the bonding pads. So from here, usually you draw little wires onto some kind of PCB, printed circuit board, like you know it from where also your chips go on today, or some kind of holder, card holder, interposer, whatever you want to call it. And these then kind of connect towards the breakout points where then the radio frequency plugs kind of get soldered onto, and then from here you go out into the electrical connection to the radio frequency. On the other side here, this backplate, which you can see, is usually connected to what is called the cold finger or the coldest point of the cryostat, so that like the chip is firmly coupled to this 20 millikelvin spot in the cryostat. There's also some factory testing report included and professional one-on-one service offered here as well as some more information about the quantum chip itself. What we can see is, for example, for this one, 25 qubits in a 2D lattice kind of setup with tunable couplers, 3 to 5 gigahertz for the XY control frequency, readout frequencies in 6 to 8 gigahertz, with a T1 time of more than 60 microseconds, T2 time of more than 39 microseconds, and a single qubit gate fidelity of on medium 99.8% and a 2 qubit gate fidelity of 98%. These values, let's say, they are all pretty good. From my point of view, from what I've seen so far, they are not, let's say, in the specifics. They are like, you can always find somebody who's performing better in some specific one, which they are optimizing for. But I think generally, from my point of view, these are like solid values here. And then you can also apply down here for a demo with them. I don't want to stretch it for too long, so I'm not going to go into all of those solutions now, but maybe let's take a look at the fintech one. So the use cases with Huaxia Bank, I hope I didn't completely mispronounce that, but probably I did. Collaboration with SpinQ of construct quantum AI models for intelligent commercial banking decisions based on SpinQ's real quantum computer. Longqiang Tsida, a wholly owned technology company of Huaxia Bank, cooperated with SpinQ to build a quantum neural network model to provide a basis for judgment on whether to remove ATM machines and to help commercial banks' intelligent decision making and the digital transformation of operation and management. So you see there's also some traction happening here and some way to learn more about that, as well as related products linked here. And then there's also how quantum computing benefits financial services 2025. I'm recording this in 2026, but looking at the news, I think it's pretty much up to date. And then the top 9 quantum computing applications and key industries available as articles here as well. With that, let's quickly go to the About Us part, because also this is an important part of the series. We also want to learn a little bit more about the companies, so let's quickly check that out. It says the first Chinese company to export superconducting quantum chip overseas. The first Chinese company has delivered a superconducting quantum computer overseas, so we have already had that twice, I think. Launched the world's first programmable desktop quantum computer, and then product sales span over 40 countries and regions worldwide. Founded in 2018, SpinQ Technology Inc. is a one-stop solution provider dedicated to the industrialization and popularization of quantum computing. With a strategy driven by both technology research and commercial implementation, SpinQ has established a comprehensive industry layout through superconducting quantum computers, NMR, nuclear magnetic resonance quantum computers, quantum computing cloud platform, and application software. SpinQ is empowering various cutting-edge fields such as scientific research, education, drug development, fintech, and artificial intelligence, collaborating with partners to build scenario-based solutions that integrate quantum computing into diverse industries, making it a true productivity tool. SpinQ is founded by a team with both international vision and commercial engineering experience. The team members are experts in quantum computing from distinguished universities and institutions internationally and domestically, including Harvard University, MIT, Tsinghua University, Peking University, and Hong Kong University of Science and Technology, etc. They make significant contributions to developing quantum computer hardware, software, and algorithms. And here you can actually browse through the history. So starting from 2018, in August 2018, SpinQ was founded, carrying the mission to bring quantum computing to life. And then it goes on to 2019 with the 2-qubit desktop NMR device that is what I was saying before, right? So it started with an NMR, even though it says it's a SpinQ, and you would think about spin qubits, it's NMR based, but there's a relation, right? And then you see here in December 2020, so this is like almost, this is more than 2 years after the funding, SpinQ completed Series A round of financing of tens of millions of renminbi, and then all the way towards here. So there are many points here, right? So there's the Series Pre-B round of financing of nearly 100 million renminbi, accelerating the commercialization of quantum computing. Many other points here. Has successfully hosted the second SpinQ Cup Quantum Computing Challenge camp, boosting the cultivation of quantum technology talents. So also actively working on building a community here. Here's something about PRX. So probably some publications there. In December 2024, SpinQ was listed in Investors 2024 Top 100 Most Investable Companies ranking 2025, and that's probably here the last one. In July, announced the completion of a Series B funding round worth several 100 million renminbi, including investors include CCB, private equity investment management company, and Liangxi Sci-Tech City Development Fund, Startup Investments, Huaqiang Capital, Yusong Fund. So many different investors that are active in that. There are also some honors being put out here, and you can see Quantum Innovation Summit. So some of them, they are, let's say, I think purely Chinese. Other ones like this one seem to be probably also outside China. So very strong traction there as well. The company itself is based in China. I think I've mentioned that before. And then let's quickly see. I think I had that already. Let's quickly also check out on the news site as a last part of today's series, because I wanted to quickly go with you into this Series C announcement here. So SpinQ secures hundreds of millions in Series B funding to accelerate technology upgrade and commercialization expansion. That was in July 2025. And I think that's everything that I wanted to look into for today. I hope you liked it. If you found it interesting, then please make sure to subscribe to this channel to not miss out on the next episode. And with that, as always, stay hydrated and see you in the next one. Bye bye.